Hello, Algebra 2. Hello again. Um, Chapter 6, Section 6, Part 2. So, in the first part, we talked about how we got the number e, that irrational number, which is called the natural number. Um, and we used it as the base of an exponent. Well, now we're going to use it as the base of a logarithm. This is called the natural log, when e is the base of a log. The number e, remember e is a number, not a variable. And when e is the base of a log, we call this a natural log because e is a natural number. And the natural log function, so log base e of x, is abbreviated, can be abbreviated as ln of x. Just like the common log, log, without a base, means base 10. Well, we have a log here, ln, which is log of with base e. We just abbreviate that ln. I make my L a little bit more cursive. I don't know why. It's just something I've done all my life. And this is on your calculator. Happens every time. Just restarted my computer last night. Okay. So here's my calculator. So let me move this calculator over here. So on your graphing calculator, you have the log button here, which is the common log. Right below that is the natural log button, which also, by the way, I didn't mention this in the last section. I didn't think about it. I showed you that the e number is over here, and you can do the power of. There's also second ln. This is the natural log button. Is e to the power of. It just puts the base number e and then the power of caret exponent button all in one. So that can help you though. It's really might be kind of hard to see in the YouTube video, but this in blue is e to the power of x, and this right here, ln, would be log to the base of e. So you can see how they kind of, same with the log, the common log button has above it 10 to the power of x. Well, that tells you what the base of this log is, because they're pairing those up for a reason. They're pairing up the natural log with the exponential form of the natural log, using the second key for a reason. So, but my whole, that's a little bit of a tangent, sorry, but my whole point was that this is ln of, the ln button is log base e, as right here. So we're going to use that in this section. These notes shouldn't be too long here. But the first thing we're going to do is just use the natural log function on your calculator. So let me put this over here. Let me turn off my camera for a little. Still hear me. So example 3, because this is part 2 of section, so that's why we're starting with example 2, because it's part 2 of this section. We want to do ln for 2, when ln of x when x is 2, when x is 1/2, and when x is -1. So you just come over here, ln 2, there. That's all you have to do. Use approximately equal to. This is saying e to what power gives me 2. And this whole decimal here, 0.693, put 3 decimal places down, use an approximately equal to. But this decimal is what e to the power of, second answer, is what gives me 2. Okay? Or e, and then if I approximate it to 0. Because I don't want to type a bunch, I'm just doing 3, you're going to get something close to 2. See, that's pretty close to 2. All right. So the second part to this is, what is ln of 1/2? This is e to what power gives me 1/2. Okay, well that's going to be negative 0.693, because the only difference between these is their reciprocals, and power of negative gives a reciprocal. You can double check this. And get that. Now, so see, that's pretty close to 1/2. 0.5 is 1/2 decimal form. Now, keep in mind that e is an irrational number. So because e is irrational, you're going to get irrational answers out of this, unless what's in here also has an e, what's inside the natural log, because e to the power of anything is going to give you, well, I shouldn't say anything, but e to the power of an integer is going to give you an irrational because e is irrational. So if I take e and I try to do something with it, because you're dealing with an irrational, it's going to bring, it's kind of like multiplying by pi. If you multiply by an irrational, it makes everything irrational. Generally. I mean, not always, but most of the time. It doesn't have to be the case. But usually if you're dealing with irrational integers, you're going to get irrational. So just keep that in mind and use approximately equal to whenever you round. So then the last one they want us to do, and you can see the answers there because of the way these notes are, but is e to the, or natural log of -1. Well, e to what power gives me -1? As I've said over and over again, you can never have a negative inside your in any log, not just the natural log, any log. You can't have a negative because you can't take a base and you can't take a number to a power and switch its sign. Powers don't switch signs. Okay, negative exponents do reciprocals, right? That's what we saw right here. Negative exponents cause reciprocals. 2 to the -1 is 1/2. Nothing negative, nothing changed about the sign. It didn't go to -1/2. So you can never get a positive base, and you can never take a positive base and get to a negative answer, or a negative value, I should say. So that's going to be an error. So you just write undefined or error, or don't write 0 because 0 is a number, but write something like undefined. All right, I think there's 2 examples, and then we're done with this section, and then we will have natural log. We will have one more section, and I'm not going to give any quizzes or anything, so if you saw a quiz in that list, don't worry about it. But there's still one more section, and then there's just a recap of the entire chapter that we'll be doing. So for the rest of this year, so that's it. The natural logs will be coming up in the next section now. How long does it take for an investment to double at an interest rate of 8.5% compounded continuously? Excuse me. So compounded continuously, referring back to the part 1 of these notes, the formula for compounding continuously is the final amount is equal to the principal times the number e, okay, to the power of the interest rate times the time. But they're asking us, how long does it take? So they're asking us for t, okay? They give us the interest rate, e is the number, and they don't give us a principal, and they don't give us a final amount, but they do tell us that the principal doubles. So the final amount, whatever p is, will be double p, so 2p. And then you can cancel out those p's, because whatever it was, if it was $100, we're looking for 200, right? So you could divide both sides by 100 and get 2. If it was $1,000, we're looking for 2,000. Divide both sides by 1,000 and get 2. So hopefully you get the point there. Interest rate, make sure you put that in decimal form. Form 8.5 is 0.085. And so now what we need to do, now that the p's are canceled out, we need to solve this for t. And because that's an unknown in the exponent, the whole reason we learned logarithms was because it allows us to solve for unknowns in exponents. And we weren't able to do that before logarithms came along. Now that we have the natural log, we can do one of 2 things. We could take the natural log of both sides. The natural log has base e. So this is a situation where you have base e of e to a power, and those e's cancel out. And then but you do have natural log of 2 on this side that we'll have to look at. The other thing you could do is just convert this to exponential from exponential form, which is what this is. Base to a power equals a value, to logarithmic form. And if you were going to do that, you would take base of e, okay, sorry, let me start over. If we're going to do that, we're going to take log base e, which is what this is, of 2 is equal to the exponent. Okay, so this is converting it to logarithmic form. This is taking the ln of both sides. Remember, there's two ways to do that. Either way, you're going to end up with ln of 2 is equal to 0.085t, at which point we can divide both sides by this decimal and then use our graphing calculators to, I think I can fit this here without turning my video off. Clear that out. So we do ln of 2 divided by 0.085. Again, irrational number. You're going to get irrational numbers for this. That is approximately equal to 8.15 years. So what is that, about 8 1/8 of a year? So we were able to figure out how long it would take to double interest rate or an investment if it's compounding continuously. A little over 8 years. Okay, so now what this would be here in class would be an example where I would then let you do it. So if you're a diligent student, I know that you are, you would maybe look at this problem, pause the video and try it, and then see if it was what I am about to do is what you wrote down. So how long does it take for an investment to triple at an interest rate of 7.2 compounded continuously? I'll give you a moment to pause and try this problem on your own. Maybe I should just wait 10 minutes of silence of me just staring. No, I'm not going to do that. I don't have the time. But in this case, tripling means that P will be 3P, or A will be 3P. P will go to, and my interest rate of 7.2 goes to 0.072. I'm plugging that in. P's cancel out. This is very much like this problem with different numbers. Taking the ln of both sides, that allows these to cancel out, giving you just the exponent by that one property, or you can just rewrite this in logarithmic form. You can divide both sides by the decimal once t is no longer an exponent, and putting this in your calculator, ln of 3, make sure you close the paren. That's an issue that some students were having with, no, I don't know if it was logs or what, it might not have been in this class. But you do gotta, if you have an open paren, make sure you close the paren, divided by, because if you don't, then you're putting the division inside the log instead of outside the log. 15.26, it would round up to 26. Use approximately equal to. All right, so I'll have bookwork, saw something there, but don't go by anything in the video because I may change it from what I gave in the class, so double check what's on Google Classroom. Don't go by what you might have seen in the video at all. So, yep, that's it for part 2 of section 6 of chapter 6. Thank you and good day.